Hello, everyone. Jim. Sorry for my delay here. Let me approve everyone. Many we have 30 or so. Yeah, the you joining. Good morning, good afternoon, good evening for everyone. Be welcome to the lesson 14. Get that correct. Sorry about that. Here at the top. Welcome to lesson 14. Today we're going to continue where we stopped yesterday, using scaffold ETH for building your first front end and integrating that with the blockchain, integrating that with some API calls, and then I'm going to introduce the subject of backend to prepare for tomorrow's lesson. Okay, why we need a backend, how we're going to connect the blockchain with the backend, and how to prepare for Thursday's lesson where we're going to speak about oracles. So full stack week, getting your front end connected to the blockchain, getting your backend connected to the blockchain, your front end connected to the backend, and then the blockchain connected to your backend. So full cycle. Okay. Let me ask, how's it going so far? Do you have Scaffold ETH running on your computer? Are you able to interact with the Hello World smart contract? It's going well. From yesterday to today, I had 0 issues open on GitHub, which means that either it's all working correctly, or if you have issues, you haven't posted your issues. So I don't have much of a metric here. Good. Mark, you want to ask something about the scaffold ETH?
Yeah, Jam, everybody, just 2 quick questions. If you could restart, if it's possible, because I hadn't time to see the previous lesson from the end of the last lesson, I mean, from the blockchain integration part, adding the smart contract and what else, if it's possible. And one more question, this way of developing the front-end part by using scaffold, it's something done just and solely for the blockchain field, I mean, in other kind of context, we are going to use React or what else?
Let's see if I got your question correctly. First of all, for review, yes, I'm going to pick exactly from this line 22 today. So I'm going to show these changes and roll back. Don't worry if you missed the last minutes of yesterday's lesson. I'm going to show that today. For the second questions, Scaffold ETH is a starting project, a scaffolded project that you can gain in speed by using React with Next.js. So would apply for any normal web application development that you would see with everything already pre-configured. Okay, I'm going to mention some of those things today. For example, Wallet Connect, connecting the correct provider from Wallet Connect here, configuring it properly here, putting the correct IDs, the correct wrappers, and everything. These kind of tasks, they would consume you a few hours, let's say 20 minutes, half an hour each, and then you might have questions, you might do it wrong, it might give you problems, you might have security issues, So Scaffold ETH solves all of that for you when you start on this project, okay?
Okay, so it's the best choice for developing front-end part in the blockchain context, let's say in this way.
Yeah, whenever you want to develop an application that you need to connect to a wallet, that you need to send information to a smart contract, receive information from smart contracts, Scaffold ETH is a great choice. Okay. Of course, you could build all of that from scratch using React or other tools, but Scaffold ETH is going to save you a lot of time. Okay. Is that clear for everyone? And it's a free project. It's managed by the Build Guild. It's open, so it's not advertising a product from someone else, my company. It's a community resource. It's common goods. Okay. Arda, you have a question?
Yes, sorry, I missed the end of the lecture yesterday. But so I sent a message to Nevin, but I'll send it again. The videos are not coming on time, so we can't really, you know, make use of them on time if we miss a lecture. But other than that, so I've gone to the what was it called? The Realm Cloud, and try to create the next public wallet, connect project, whatever thingy. Here's a problem. Like, so I didn't know which one to pick. Do I pick the API or the wallet? And then there's a newer version. Should we use the newer version? Could you help me with that, please?
Yeah, sure. The guide is here on this link of the wallet kit, and that is a getting started for the app kit that we're not going to use in this bootcamp, and that is the wallet kit that I've posted here. Okay, so if you follow this link, let me just get the correct one first. Wallet kit, getting started. Let me see if I find. I added this last week, so I didn't have much time to do this. But let me see if I get this article correctly. How to get started? This. So you're going to have the step by step here. Okay. I see the confusion. This is for the app kit, right? Okay, you are correct, Art. I should have specified that better. So this is the article for you to get started with the app kit, which is a good component too. We're going to have a workshop from Rion in the 7th week where they're going to present this app kit. So you can follow this exercise should you get ahead of time. And you would create a project and pick this option, the wallet kit that I've mentioned yesterday. And then you would have the ID at the end. Let me see if they show this picture. They would have something like this, an ID, and then you would put your ID on end file. Okay. The best way to solve these kind of things is opening GitHub issues. I can send all of the links there. Here in the fly, it's a little difficult for me to find the information efficiently. If you open this in a GitHub issue, give me like 5 minutes or so. I'm going to fetch all of this link, all of this explanation. I'm going to send there for you. Okay. I'm here to serve. You have me for 24 hours, not for 90 minutes. So open those GitHub issues. I'm going to send all of this content for you. Okay. So 24 hours, no, I need to sleep. Let's put it like 18 or 20 hours per day. It's good, right? Ping me with those issues. Don't spare me. Yes, Dante? Did you raise your hand?
Yesterday I was able to connect to Scaffold ETH and follow along. This morning though, I'm getting 2 issues.
So let
I don't
me
know, maybe I can cut and paste what the issues are.
Yeah, let me start with this command, yarn start, inside the folder of scaffold ETH2. Run this command, see if you can run it correctly. And then we're going to open 2 more tabs. One, I'm going to run the command of yarn chain, like we did yesterday. And the other one I'll keep here for running all the things that I might need in my terminal. Okay, so I need yarn start and yarn chain. This compilation is going to take a while, so I'm going to open the localhost 3000 here. It might take 2 minutes or so for it to compile. Yeah, I'm going to leave it here as I start my explanation. Okay, so Dante, check if you are in the correct folder. If you have installed, do yarn start there, do the yarn chain. This should properly start your application. Okay.
Yeah, I did. Okay, so I did the yarn start, but I forgot to do yarn chain.
Okay, no worries. So this is why it's good to review. Okay, Lauren, do you have a question too?
Yes, when we do yarn start, shall we wait the end of this process to start yarn chain, or can we launch them in parallel?
You can launch in parallel. Okay.
Okay.
It's going to be needed when the request is sent.
And for yarn deploy, is there a prerequisite in terms of yarn start or yarn chain?
I'm going to show that now.
Okay.
I didn't execute yarn deploy. I'm going to show the application, and we're
I'm
going to see
calling to
that.
get feedback from yesterday, sorry.
No worries. We're going to see that there is no smart contract here. Like, well, let's go for the bug contracts. We don't have any smart contract here. This might take a little while to compile again. Okay, so why there is no smart contracts there? We just initialized that blockchain. We don't have anything there. Okay, we are trying to read a smart contract that's not there. I have hello world and your contract there, but there is no state. I cannot connect to these things because there is no smart contract deployed. Okay, so ideally we need to clean those files. How to resolve this? I can just do the deploy script. Yarn deploy. This is going to run those two scripts, the deploy your contract that is already there on the default version of the scaffold ETH. And we created this deploy hello world yesterday that is going to deploy that smart contract called hello world here. Okay, so the code is very simple, similar to what we did in VM. We're going to pick a deployer. We're going to use this deployment package from a hard hat runtime environment. We weren't using that before, but here they are using. It is their design choice. And we're going to deploy that to this account, okay? This design choice is good because they can keep track of those deployments and all. But here it is, just to simplify, it is deploying those scripts, it's running those scripts, okay? So it's going to execute those two deployments. And then I'm going to see them in the front end. You have a question, Arda?
Yes. So when you say put this in the .env, it's in the scaffold folder under hard hat folder, right?
It can be in the root here in the
Okay, in the scaffold E2 folder. All right.
yes, the package.json where you're going to run the commands. Okay, it's going to load the environment there. If not, you can put them inside these environments that you have in the Vercel here, the .env.example, and then you would put them like .env.local. You would load them inside the application. Okay, in the Next.js here. Okay, for any questions about the homework of Realm, I do have the contacts with the Realm team too that is working together with Encode. So the best way to proceed with that is to ask questions with GitHub issues. Anything that I know how to answer, I'm going to answer directly. Anything that I don't know, I can ask the Realm team to answer there in the GitHub issue. Okay, so for any questions about this homework, Arda, you can open the GitHub issues. We're going to get that dealt with. Okay. If everything fails, speaking about the configurations, you have the scaffold.config.ts here, okay, that you can replace those configurations like we were changing here for target network. We're going to do that today. And you see that you have the API keys from Alchemy and the Wallet Connect project ID, okay? If you put your keys here and then you commit that repository, you're going to leak your keys. This is why it's not that good. But if you are having problems with the environment, you can put the keys here, just do not commit that to the repository, okay? Then this should work. Returning to today's lesson, we are running those two scripts. So we deploy those two smart contracts. Now, when we go for the front end, we're going to see the state of those smart contracts here now. Hello world and your contract, okay? And the clever, the beautiful, the amazing features that we have here is that whenever we change something in the blockchain, for example, I'm going to put a new text here instead of hello world. I can get this information there. I need to grab money from the faucet first. I'm going to have this information there for visualizing that in the front end now. We created that little snippet in the page.tsx to use this component of example contract read, to use this hook from the scaffold read contract. By just passing the contract name, we can go there and display this information at the time of the last review, anything like that. Okay. So this is the review that we did yesterday, introducing to scaffold ETH. Any questions up to this point? Getting your scaffold ETH working correctly and using their features? Pay attention here that we don't have hard hat. So everything that we use with hard hat, we are going to need to replace for using VM, WAGMI, and all. I'm going to guide you through this. in today's lesson, but all of the, let's call it infrastructure, all of the pre-required configurations are there. We have wallet connection, we can call the blockchain, we can send RPC commands back and forth, receive information, listen to events, explore the state of the blockchain. We have all of that in place, okay? So today I'm going to show how to code a front-end application, how to use the correct components by tweaking this page.tsx. The whole lesson is going to be about that. Okay? The whole lesson 14 is a coding with Next.js, implementing a function to get information from the network, get information from the wallet, get information from the balance of the user, get information from smart contracts using VM directly for us to understand what's happening under the hood, how to get the wallet info with the VM, how to fetch public off-chain data like normal APIs. We're going to see tomorrow that it might be useful to have APIs for your project, for a blockchain project. Okay, I'm going to show some examples of that happening. For example, OpenSea, even MetaMask, they have those APIs. I'm going to show that, how to use. Next.js allows us to use APIs to, just that we want to have a static application if you want to serve this for like end users using IPFS, whatever. So I'm going to show how to build a static website with the Next.js, so we don't need the backend of it. And then I'm going to use another framework for building the backend. Okay, this is all that we have for today. I'm going to go slowly so I can onboard everyone that is not front-end developer. Okay, it's basically copy and pasting, so you don't need any knowledge, you need attention. Okay? Of course, if you know React, Next.js, if you understand Tailwind, and now this is going to make much more sense for you. But if you are a beginner, you just need to pay attention and copy and paste correctly with me here. Okay. So we're going to start with this initial code. We're going to undo some of the changes that we did yesterday with this example contract read, and we're going to start just with this. Okay, this code. Do not replace everything like I did. We still need some of the imports on the file. Okay, we need this use client, we need this next page. Okay, so I want you to get used to some of these things. This is a statement being passed for Next.js. I know it's ugly. I know it seems like a code smell. Okay, I'm not going to prove you wrong. I agree with that, but it is what it is. So we have to have this statement in the beginning for Next.js to acknowledge that this is going to be processed and rendered their client side. It's not going to be rendered in the server side, okay? Which is good for the app. Might not be the most performatic things for people in low bandwidth networks with like old computers or old cell phones and all, because you wouldn't need to use some of this resource for the client here. But this is very good for the apps. The more you run there in the client, the more safe it is, the more tamper-proof it is, okay? So we're going to run that in the client. And we need the next page from Next.js. That is a way to create a page in Next.js, okay? So I'm going to keep those two, and I'm going to paste everything, okay, for us to keep that file. You also need that last line, okay? Export default home. This is a statement for your file, your page.tsx, to export this component out of it. Otherwise, all the pages wouldn't be able to import it, okay? This is a design of the architecture of the framework. You could put it here, or you could export this const home there too. So that now people importing that file in other places, for example, in the layout TSX or in the route, actually, they would be able to access that page from that file. This is something about how TypeScript works, how the framework Next.js would resolve this file, okay? So if you stitch that correctly, you are going to have this piece of code that I'm going to send for you in the chat. Okay. If your page is not working, just copy from the chat, paste here, format this, and you're going to have a state like that. Welcome to Scaffold ETH2. Get started by editing this page, and here we are. And things that we change here we are. I'm here. Things that I change here, they would appear here as soon as the page finished compiling. You see? Any change that we do in the code get reflected here in a few seconds. So this is the starting point for today's lesson. I'm not going to explain much of the structure of Next.js. I'm not going to explain much of the React syntax here. It's more about explaining how to use the blockchain integrations inside this framework, because then you can search for those other tutorials later. If you don't know how to use Next.js, if you don't know how to code on front end, there are month-long bootcamps, especially for that out there in the web. Okay. Maybe Encode would like to have some of these bootcamps in the future. Send some feedback to them. Maybe we have like a front-end 0.10 getting started with coding web apps. Okay, today we have very limited time. Let's focus on the blockchain integrations here. Again, anytime, feel free to raise your hand and stop me. I'll keep going. You should have this initial code on your page with these 2 lines before and this line after, so that your application is going to work. We're going to create one integration with the wallet client. Okay, we're going to use this hook use account from WAGMI. That is going to wrap the VM call of accounts inside the React hook, inside the React state management flow of work. Okay, I'm going to explain why this is important. I'm going to copy this function, wallet info, and as you paste here, you are going to have some problems. I'm going to copy this function and I'm going to paste it after the page body function. Okay. And we have this problem here in line 36. Increase the zoom a little. Okay. We have this problem here in line 36. We are using this use account hook, but we don't have this import stated in the code yet. To solve that using VS Code or Cursor, you can do Control dot or Command dot, or click on this and then you should have this menu. This is going to automatically apply this fix, even without using AI. There is no LLM involved. This is just IntelliSense, because TypeScript knows that there is this import of use account from WAGMI. So if you click this here, this is going to fix your file for you. It's going to add this import of use account from WAGMI. Okay, this model, there is a documentation for that here. Let me open this doc, showing that you can use this hook called use account to get the return time, to get the address of the connected account, the chain of the connected account, the chain ID, the connector, the booleans here. Okay, so this is similar to what Hot Hat was doing for us. Now we are doing the front end with WAGMI, with these hooks using React. Okay. So if we save that now, I'm going to have that function wallet info. Let me format this properly. So this function is going to use this hook use account to determine the address of the connected account. It's going to determine this flag whether the account is connecting or no, if it is disconnected or no, if I have this chain connected or no. And depending on those variables, I'm going to display this or that or that or that. This is conditional rendering. Okay, React is going to display different things on the page depending on the depending on the state, depending on the values of those variables. There is an algorithm here. Okay. This whole logic came there from the idea of PHP. People from Facebook maintained React for a long time. They were using PHP, so they built React just as the way that they would build PHP, that you have a server or a processor, an algorithm encoding the page as you go. And then you have this mixed up logic of JavaScript together with the HTML that you're returning. Okay? All the frameworks would do that differently, but this is the way that React is going to do. So to display this wallet info, we now need to put it here in the page. The next instruction that I have in the documentation. I'm going to pick the page body, and I'm going to add this component of wallet info there. Inside the page body, we saw that everything that we change, like if I put something here, what happens in the page? If I put something there, if I put something here, it's going to appear, right? So if I put this wallet info, it's wallet info, like this, I can close in the same icon, or I can do like this. Doing this or doing that is the same thing, okay? Going to be interpreted in the same way. This is a little more cleaner, okay? I need to fix that in a while. So we saw that anything that we put would be displayed, like I'm changing here. So if I put this, it's going to be displayed for me. Wait, I'm changing here. So if I put this wallet info definition, is going to render here this component of wallet info. Ideally, we would put that in a new file. Okay, just for the sake of speed of development here, we are putting this in the same file. And this is the block of information that I have. Your account address is this, connecting to that network. Okay. Yes, Dante?
Yes, I must have missed how you fixed the use account on the function, the wallet info function.
Okay, so when you put the user account here, you're going to have this problem, right?
Yes.
We have a lot of similar situations in this lesson. So you're going to do control dot or command dot, and you're going to suggest the quick fix, the first suggestion from the quick fix that is going to import this method for you. Okay. Got that?
Yeah.
Okay, good. And this is dynamic already. This is reactive. This is responsive. If I change my wallet here, let me disconnect. This message changes very quickly. Wallet disconnect, connect wallet to continue. And then I can click here, connect to this burner wallet, and it's going to show my account here. Okay, you see how fast it is? Maybe it's your first time doing this kind of application, but this connection, this fast connection with the wallet, used to take a few hours for you to set that up, connect with the MetaMask SDK, and then add all the wallets and all. Wallet Connect, in this case, Realm, it is solving that very well for us, very neatly. It's very quick to just use it here under WADMI. If you connect it properly, it just works like a charm like this. Okay. So question here up to this point. See if you can do that. If you can select a wallet, and it should display here. Why are we using this hook? Why aren't we just defining the variables directly and then calling it like a normal script? Here, we are coding a component for React, and we need to mind some of the rules, some of the structures that React would do, because we are not coding the page here. We are coding the factory that is going to create the page. We are coding the page maker. Okay, this is going to be injected in the life cycle of this component. So if I define something here, like const my var equals to math.random, and if my var is higher than 0.05, you're going to return something like this. My random number is my var. You don't need to code that. I'm just explaining about the structure of React. Then you would have you would expect my random number is higher, is lower, no, is greater than 0.5, and my random number is less or equal to 0.5. Okay, forget everything else. So I'm having a random variable, and depending on the variable that I have, I'm going to display this or that, right? Seems like a very simple script. If you pick the logic of what we did in the past lessons, you might find this very reasonable. Okay, depending on the variable that I have, I'm going to have this or that. And then I have my random number is greater than 0.5. Let me navigate for that page again. It's less than equal, it is higher than, it's greater than, okay. So every time that I would render the page, I would have a different result here, right? So this might give us problems, this issue here, because we have a hydration error because the server render an HTML that didn't match the client. So how to solve this hydration error? We throw water at the server, right? It's missing water. We need to remember to keep hydrated. Just kidding, people. Just kidding. Do not throw water in the computer. This is a thing about React. Like React is composing this page in the server and then in the component, and then one thing generated different to the other. In my component here, it was generating this. In the server, it was generating that. So React is kind of crazy, and I'm not saying that you shouldn't use React or that you should avoid it or whatever, but if you are a newcomer, you should be mindful that coding specifically for React comes with a bit more of complexity than coding just a normal TypeScript script that you would do logic sequentially. Here you have your logic of your application, mix it together with the logic of the life cycle of the components. So some things that you want to do directly, I want to get this value, multiply and do this and that, you cannot do directly. You would need to use hooks, and you would need to do state management and all, because this is very important for how React, especially Next.js, to work. Okay. We did set use client above. It should be done 100% inside the client. Yes, but also we need to keep track of some of the changes on the end user with the server. Because this is how Next.js wants to keep your application super performatic and all, just updating the things that are changing. So if the version that they have in the server is not the same version that they have in the user, they are going to lose track of these changes. So they cannot push updates specifically in the places. They would need to update your whole page, which would be less performatic and would defeat the whole purpose of server-side rendering and the performances of these frameworks. It's good to have good performance. Yes, it's just that now we are dealing with so much things that we don't want to deal with that. I just wanted to do with the blockchain part, okay? But yes, by using React, we come preloaded with all of those complexities. We need to follow the way that React is. So this is why we have those hooks. We need to follow it very closely, okay? Tomorrow, I'm going to show some backend code using Node.js based frameworks too. It's going to use JavaScript and TypeScript, but it's going to be much more straightforward because we're not going to have this complexity of the front-end framework. It's going to be straightforward calling things that we want to call. Okay? So things are going to make more sense for what we did in the bootcamp. For now, we need to use those hooks. For example, this user account hook from WAGMI to bridge what we did with VM with the insanity that React ask us to manage here at the same time, okay? So it's kind of given. We need to use that. There is no way to avoid using these hooks. It's necessary for, it's the price you pay for using React is necessary. It's going to pay off well when you use those components, but for now, we gotta just accept that, okay? So we have this component working. We have this wallet connected and we can see the address. If we change this wallet for another wallet, we disconnect and connect another wallet. For example, my MetaMask, I'm going to see my address from MetaMask here. And if I change my wallet to MetaMask, I'm going to change it here too. I have this seamless integration, Wallet Connect, MetaMask, Ledger, Coinbase Wallet, Rainbow, and many others. I can enable a lot of wallets here. If you create your own ID in the Realm Cloud, you would be able to manage all of those connections there on your project, okay? Your keys and all. So now I'm connected to this wallet. If I change it there on MetaMask, let me change for my second wallet. Okay, and let me connect that to the website. And connect, so connected. There should be a button here for it to connect or disconnect. But whatever, you saw that I can connect different ones here. I guess I would need to disconnect and connect again with accounts too. Connect with MetaMask. Now I would need to connect it to accounts too. I guess I can select those accounts. Use it to be a checkbox so that I would select the accounts that I would want to connect. I don't know what happened here. Okay, yeah. Now I'm connecting accounts too. You see? Whatever account I pick here, it's going to be displayed in the page. So that is a live sync. And we're going to use this for signing transaction, for displaying balances. We're going to use the same channel of connection for everything that we did with the scripts in the past lessons of this bootcamp. Okay, so let's go with the next example. Let's interact with the wallet. Let's implement a wallet action. Okay, let's implement this hook of sign message. I could implement the hook of send transaction too. I could implement a hook of mint NFT, whatever. I interact with smart contract to mint tokens, NFT, whatever. Here, I'm doing a very simple implementation that is signing a message. I'm going to use my private key stored in my MetaMask or stored there in the burner wallet, and I'm going to sign a transaction without revealing that key for the front end. It's going to be done entirely in the wallet application. So I'm going to copy this wallet action here, and I'm going to paste it under the component of the wallet info. I have this wallet action here. And I have two problems. One for the hook of user state and the other for the hook of user sign message. Okay. We are going to solve them in the same way. Remember how we solved the previous hook? We're going to ask it to import from whatever they think that they would have. So use state, it is a hook from React. It doesn't need WAGMI for that. It is a hook from here, React. And use sign message is a hook from WAGMI. Okay, so I accepted those suggestions. They are not AI generated. They are IntelliSense, it would work in VS Code, whatever you would do in Cursor would work in VS Code too. And then I add this import line 4 and modify this import line 5 here. Okay. Now it fixed my wallet actions. So this is going to return a form.
I apologize. What?
Yes, Dante?
Sorry. What was the option when you go into that menu to update it real quick?
The first option. So it would pick the first option there. And would pick update import. Okay. That would fix your code. Okay. This would add those 2 lines of code. Would add the line 4 and it would modify the line 5. Okay. So this is going to return a form for us with this title, testing signatures, and then a label text to ask the end user to enter the message to be signed. And then there is a button that you can click here that is going to use the signature message being passed by the user in that input to execute that function, sign message. And this function is already coded for us. It's already pre-configured for us here inside this hook of use sign message that is going to return the data, the error, and all. So this is the React syntax using Next.js for building that with those components from Daisy UI, with those components from Tailwind. Okay, so it is returning all of this code block, and it's also using WAGMI injected in that code block to govern some of the features, like signing a message and displaying the signed message. Okay. I'm going to display this wallet action here inside this if address. Okay, because if I don't have the address, it doesn't make sense to display that component. Okay. So I'm going to modify the wallet info inside the if address. At the end, I'm going to create that wallet action component call. Okay, so wallet info, I'm going to display this wallet actions here. Yeah, that's a good suggestion. Let's do it like that. Okay. Going slowly so you have time to do that on your side. Look for the correct place to insert this code. Insert there the wallet action. And this is going to call this wallet action component to be handled here in the line 45. Okay. This is what we have. If I disconnect, I don't have this card anymore. But if I connect my burner wallet, this is going to execute line 42, 43, 44, 45, 46, and it's going to display this. Okay. And look how interesting. I'm going to ask something to be signed. Hello there. And if I click on sign message, it's going to use my burner wallet to do the signature. If I do that with MetaMask, here I'm using MetaMask Flask, but it behaves the same way as you would have MetaMask, normal MetaMask. Let me connect this. Yes, I still have account 2 connected. Let me see. Yes, account 2. I'm going to ask a message to be signed, like hello. When I click sign message, Wacom is going to connect with Wallet Connect. Realm is going to go there for my MetaMask and is going to ask a signature request. I guess I don't have any way to increase that. I'm sorry. But I guess you can read it here on my screen. I'm going to have a signature request from localhost trying to sign this message. And then I can confirm or cancel this. If I confirm, I'm going to have this message displayed here in this card. It's overflowing a bit, sorry about that. But you get the point. I can use my wallet to do actions now in the blockchain using my private key there inside the wallet by consuming those functions here in the front end. Okay. If I try with a burner wallet, it doesn't ask for approval. It just signs it directly. Okay. Good. Dante, you had a question?
I was just gonna say that. So basically, like you can, this would be good if you for our voting contract that we made to be able to go in and sign it, right? Be able to go in and vote.
Yes, it's exactly this week's homework project. We're going to build a backend and a front end for the tokenized ballot. You had a good vision there. Okay. So we can read the wallet and we can sign things with the wallet. Is that clear for everyone? Raise your hand if you're falling behind, if you're confused, if you run out of snacks. I can't wait for you to pick more. Hey, Arda, are you out of snacks?
I'm out of snacks, man. I got coffee though, so it's okay.
Okay,
So
good.
when we sign with the burner wallet, isn't it supposed to use gas?
So a signature can be done without paying for anything. It is just a mathematical computation. You can do
Yeah.
that even in paper. It's basically a mathematical derivation using cryptographies and hashes and all from your private key and the signature.
Yeah,
Okay,
yeah. I mean,
and the message
I
and
know,
the
I know the math part.
bro, that's good.
Yes, I'm a cryptographer, so yeah. But the my question is, so this signature isn't written anywhere then, right?
Yeah, it's just displayed the front end. We
Oh,
did not
okay.
send that for the smart contract.
All right.
Okay, but you see where I'm going with that, right? Later I can prove signatures with this. I can use that signature to gatekeep if someone has the correct message or no without display that message later, right? Okay, this is a very simple example that I'm doing here, but in the future, we are going to use this signature again. I have a lesson to explain about that. I have a exercise where we're going to use signatures in a lottery smart contract in the future. So it's good for you to open your mind on this subject. We are going to use a lot of these cryptographic features in the future as an examples of things that we're going to do. Okay, for today is just a random signature that I'm displaying the front end just to prove that I can do things in my wallet. When you do a transaction, what you're doing is actually broadcast a signature, a valid signature for that transaction. Okay, but you don't need to worry with that. For today, we are more focusing on the front end integration than in the actually workings of the blockchain. Okay, so this completes that next step of the wallet info. Okay, let's get some specific on-chain data. So far, the wallet address, the signature, that they are not reading from the state of the blockchain at all. I can do those even offline. Now I'm going to fetch the wallet balance that is pertaining to the account, to the network that I'm using to connect with that account. So I'm going to use this hook, use balance, to get the value of that account in that connected network. Okay. I don't know if this formatted is going to work. They were deprecating this. Let me test that on the fly. I tested that a couple of months ago. Let me create that wallet balance function. You can even fold those past ones. Like we're not going to use the wallet action now. I'm going to use this new one called wallet balance. Okay. So I'm going to import this hook of wallet balance from WAGMI. Yes, they are deprecating, but it's still working. Okay. I'm going to fetch this balance from the connected network. And then if I have an error, I'm going to display error. If this is loading, I'm going to display this is loading. Otherwise, I'm going to return this component here. A card body with a title, testing use balance WAGMI hook, and then I'm going to display this balance and this symbol. Okay. This means that WAGMI is going to know what is the symbol of that network that I'm connected, like ETH, if it is Ethereum or Base, Sequoia, and now Poly, if it's Polygon, Arbit, if it's Arbitrum, it's going to know what network I'm connected, and it's going to display the corrected symbol. Okay, so we created that component of use balance. Now let's modify the wallet info again to pass this parameter for the component. This component requires one parameter of an address, okay, that I'm receiving here with this type, and this is going to be passed when I'm rendering it. I don't know the address that I'm going to get this information from when I'm doing the code of that component. Okay? I don't know what is this address. So I can calculate this address on the fly when doing the call here in this wallet info. And I can use this address that I had here in the line 39. If I have this address, I will be able to use that in the wallet balance here. Okay. If you are finding this code too smelly as a 0x string, blah, blah, you can import the address from VM. Okay. You can import this address from VM directly. Like this. And this address from VM, it is exactly an alias for, wait, what's that? 0x string, you see? So it is just a alias for 0x string in most cases. So we don't need to import address from here because we just need to use the 0x string, whatever. It is one extra import that we are doing, can make the code a little more dependent, can introduce breaking chains, you know. But I agree that it also makes the code more readable. So I don't have a clear flavor here. To make things a little simpler without explaining all of those imports, I usually suggest us use 0x string. But I also see a lot of people using address, importing address from VM, choosing this kind of thing. So I prepare you for both cases, okay? It's not needed to change it for address. It works with the 0x string. It's just that this is a little more readable, okay? If you want to keep 0x string, your code is going to work just the same. And then I'm going to render this wallet balance using the address as I have connected there. So testing the use balance WAGMI hook. This is the balance that I have right now. 0.0009607 ETH for some reason. Did I sign anything with this account? It seems so. 2.99996007 blah 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 ETH. I'm not sure this is correct. Maybe this formatted thing. Maybe they changed it. Yes, maybe. We have some VM functions to properly format this data. Okay. Just formatted this. Could pick the decimals. And then we would format ether. Remember? We see that. 18, not decimals. Oh my God, sorry about that. Value. And then we would format ether using the decimals. You see the balance? Yes, for some reason I spent some ETH. I don't remember when, but I did. And if I change that for another network, like Polygon, Amption, whatever, I would automatically change the symbol name that I have here. Okay.
Could you show the code again, please?
Yes. I didn't spend gas on signing those transactions, okay? Might be something else. Or maybe it's just the big number conversion here that is doing crazy results. So this is the code. If I want to do it well, I would do the value, and I would do the format or parse. Never remember. Format ether. That value, is that correct? Let me see. Put that from here. No, sparse. I did it incorrectly. I always do that thing. The opposite. Parse ether. Parse ether should receive ether is string. Wait, no, yeah, sorry, I was correct. It would be format ether. Just got confused here. Sorry about this, bought it twice. So big int undefined is not assignable to big int. So let's fix it with this. Actually, this would be good. I guess this would display it correctly. We see. No, it is still like that. Okay, I'm going to rest this case. I don't remember when I spent this money. I guess I use it to send a transaction, something like that. But I did send the hello world. Now I remember. I did all of that for nothing. I remembered now. I spent gas for signing a message to send the text from hello world. This is where I lost money. Okay, now I can rest in peace. Let's leave the things as it is. Let's not consume more time with the lesson with this problem. Let's keep it with the formatted, but we remember how we can format it correctly. Okay. So this concludes the wallet info part. We can also interact with smart contracts just like we did a while ago. We did in the review and we did in yesterday's lesson, a way for us to use a scaffold ETH hook to get information from a smart contract, right? Now I'm going to show that how to do that with VM. So you know what scaffold ETH is doing under the hood, how you could write those custom calls to. Okay. Abhinav, I see your hand raised.
Yes, sir. Sir, I'm still seeing an hydration issue if I compile my code. I mean, if I'm launching it, I'm seeing that hydration failed because the server rendered HTML didn't match the client.
Yeah, I guess you need to give some water for your server then. Just kidding. Try and do a clean refresh of your page, like disconnect the wallet, clean refresh the page, and then connect it again. Sometimes it glitches, like when doing the live reload, and then you can stop your server, start it again. If these wouldn't fix your problem, maybe you coded something wrong. You coded some of the structure of those pages wrong. Okay.
Okay, I'll check it once again.
Yeah, if you still have those errors, you can open those GitHub issues. I can look at your code and paste the code, and we can go back and forth until we find a problem, okay?
Thank you.
Let's do a simple configuration in this scaffold config.ts, line 14 or 12. Let me see if I recall it. We had it. Package scaffold.config.ts. I was mentioning about this file. 16, line 16. They changed it for 16. Line 16. Okay. When did they change that? No idea. So we're going to change the configuration here in the line 16. Instead of being chains.hot, we're going to do chains.sepulha. Okay. We could also add an option for the user to connect to the chains.sepulha. Okay. It accepts an array of chains that we could add. Okay. To make it simple, I'm going to put just Sepulha here so that the user needs to be connected to Sepulha to use my app. We made a change to the lesson 14. See if I find it here. Okay. So changes from the line 14 to 16. I guess AI is going to get that correctly. Let me see. And then you just refresh this commit on your page. You're going to see that those changes. Okay. Maybe it should change those things there. Whatever. We'll do that with care later. Don't want to mess up the documentation. So if you pull those changes, you're going to see line 16 now. Okay. You go there for line 16 in the scaffold.config.ts, and then you change the target network to target Sepulha instead of hard. Okay. Now, just by doing that, when you connect a wallet, you don't have the burner wallet anymore. You can enable the burner wallet for testnet, for public testnets, but it's not advisable because everything that you do in your burner wallet, you are going to lose when interacting with anything that you do with the burner wallet while interacting with the smart contracts and the blockchain, you're going to lose in the next time that you reopen this app. Okay. The burner wallet is meant to be discarded. Okay, and I connected to the wrong account here. For example, this account 2, it has 0 ETH. I don't have any money with it in my testnet, in the Sepulha testnet. If I connected to my main account 1, I would have. Let me disconnect and connect it again here. And then I can assign transaction with it. I can send money around. I can interact with smart contracts. I can even deploy smart contracts using this account. Okay. Now I have, and this is my balance, 3.86 ETH, Sepulha ETH. And we can stop running yarn chain. We are not going to use yarn chain anymore. We're not going to interact with this chain. We're going to point our front end directly to the public testnet, connected to the Sepulha testnet. We could get the blocks from there. You see that we don't have the faucet anymore. We don't have the block explorer. Now we are using a real public testnet to mimic the mainnet functioning. Okay. Thanks for reminding me, Edgardo. So let's read a contract. Let's implement this token info, token name, and token balance functions, components here in this page. In the page of TSX, let me fold those orders. And I'm going to put these components, okay? Token info to create a card saying test read contract me hook to display the token name and the token balance of an address for that token. Okay. Here I can use the 0x string, or I can use the address from VM. Okay. I'm using the hook of read contract. So here we are going to import it from WAGMI, just like we did a lot of times. And this is a contract that is present there in Sepolia. You can put the address of your smart contract that you used in this bootcamp, your tokenized ballot token, or your ERC20 deployed in lesson 9, if I recall it correctly. You can use these addresses for you, if you deploy that to a public testnet, for you to get a function, for example, name, function name with name and with this API, and get a return value of it, and the balance. Oops. And the balance of a token, calling the function balance of, using the API here and here. You could get this API from the JSON too. When you use the scaffold ETH, they would give this API for us. We saw that in lesson 8 when using hardhat. When using hardhat, I just need the artifact name. It would give the bytecode and the API for us. When using VM directly, we need to pass the API, right? We are seeing here the same thing. I told you that in lesson 8. This would be useful in the future. So here we have this call from token name and token balance, using this hook on top of VM to use VM to call this smart contract. Okay. If I put that in my page, if I modify the wallet info to display this token info, I should see it there. I don't remember the name of that smart contract. Maybe it was a pizza token, something like that. So let me do some address here. You can leave a 0x address if you want, but it's 0x is string, but this address is a little more readable. And let's see what we have here. It's actually the contract of the magic token. Again, I have 0 balance on it. Okay. Would any of you provide me some token addresses that you use it in this bootcamp? Maybe your tokenized Volks token. Pick on Sepolia tokens também. I can pick on Sepolia tokens also. Sorry, got confused here. Sepolia Etherscan. To pick the tokens, view your ERC20 transfers that people are doing in Sepolia. And I'm going to pick any of those smart contracts. This Yala, Bitcoin, whatever. So I'm going to copy just a random address that I found there in the blockchain. So I'm going to copy this. I'm going to paste this address here in my code. And let's see what I'm going to have displayed in the front end. Fetching name, token name, Yala BTC. I have 0 balance on that. Dante, you share an address here. Is this your token contract for the tokenized ballot? If it is, I can put it here.
Yeah.
And the name should be something like my token. See?
Yeah,
Fetching name.
it is.
Okay. Error fetching name. Maybe this is the address of a ballot, no? Or maybe I did something incorrect. Sepolia. Let me see. Verifying that you are human. Is that necessary? What if I'm an AI? This is taking a while.
If you're an AI nowadays, you prove that you're a human better than you are.
Probably, that's correct. Eventually, an AI can start a lawsuit like, I'm being discriminated. I can't access this website. I have constitutional rights to access this website. And it would appeal for a court, a judge. Dante, I guess I see this contract here. I see this contract deployed, but I don't see the ERC20 transfers. Let me see this one. Contract creation. You did create those contracts, right? Maybe should be one of these. Let me see your contract, Martin. But the contract itself is not important. I'm just trying to prove, okay, I have this my token here. So I'm just trying to prove that now I can read any smart contract, any function name, any function parameter or whatever. Let me paste this here too. So that I can interact with the blockchain from my front end without coding all of that myself. Let me try this again. Token, my token, and the balance 0. Okay. Disconnected, connect the wallet to continue. MetaMask Flask. Okay, that was quick. Here I have. Okay. So we can connect to the blockchain. We can get this information back and forth. We can sign transactions. We can send transactions to the blockchain. Okay. We have all of those powers, all of those functionalities. Art, do you have a question?
Yes. So I'm testing our front end in both Chrome and Firefox. And when I connected to my MetaMask in Chrome, it started giving the one issue, but it doesn't give an issue on Firefox. Do you have any idea why this is happening?
What wallet are you using?
My MetaMask Folio wallet.
For both, right? Yeah,
Hey,
sometimes
Art.
these problems they come from MetaMask directly.
Arda, I have the same problem, but reversed.
Man, they're
It
trying
works
to
on Firefox
make us
and not
not
in Chrome.
learn.
It's not working on Firefox.
The
Yeah,
React
it
people
happens.
have something against us.
The Brave wallet also caused a lot of problems. People using Opera, that's based on Chromium, Edge, like Internet Explorer. So different browsers, they would have different problems with their wallet connections. Okay. And this is one of the best wallet connections that we have right now with Wallet Connect from Realm. Imagine if you would implement all of that by yourself. Okay. Someday, a user is going to access your website from the browser of the PlayStation 3, and you will need to provide support for that user. So it is a huge amount of work for you to do. It's not good for you to take this work on yourself, unless you are a wallet company. If you're not, you don't want to handle the wallet connection yourself. Probably you want to use safe and community vetted packages like these to manage your connection. That they would deal with all of this madness for you. Okay. Daddy, you have another question? No
No,
worries.
sorry.
So this is basically the summary of blockchain integrations. You can look at all of these hooks that we have here on WAGMI, that they would encapsulate the VM hooks, and you can do a lot of things. You can ask, for example, given an ENS name, what is the address? You can do this hook. What's the proof of that transaction? Let's read the contract. Let's read a lot of contracts in one go. Let's write a contract. Use write contract. So how to do that? What's the address? What's the function name? What are the arguments? What should come out of it? So you have a lot of hooks that you can use now in your front ends. And if you want to use the scaffolded hooks, you even have more integration with the contracts that you are deploying. Okay. If you are integrating, for example, with a DEX, with a Uniswap, and now you might want to use these hooks from Wagner. But if you are integrating with the smart contract you have deployed, Scaffold ETH is going to give you all there, so you don't need to pass the ABI and all of that. Okay. That concludes the blockchain integration part. I want to increase the scope a little more, preparing for tomorrow's lesson, because every connection that we are doing with the blockchain is calling an API, RPC, JSON RPC connection server that is managing by another person, by another company. Probably we are calling Alchemy here with those configurations that we have in the scaffold.config.ts, the Alchemy provider, that you can use your key to if you want to have more rate limit. We could be connecting with Infura, with Morales, with QuickNode, whatever providers that you want to have for RPC connections, but still you are connecting with someone else's servers. Unless you are running an Ethereum node on your computer, which you can, and you can host your own RPC server, which is very noble if you do. But if you're not doing that, you are connecting with someone else's servers. So let's increase this scope for this page, and let's connect with someone else's server for doing something else. Okay, whenever you want to connect with the server for get the weather, get the current price of some asset, getting social media posts, anything that is present outside of the blockchain, you can use this kind of components, this kind of calls too. For example, doing a fetch, data fetching on React, using fetching from client side that you can do in Next.js. You could do this fetch from server side and pass for the client too if you want to do caching, you know. But for the apps, I would not recommend that. I would recommend doing everything from the client side. Okay. You want to protect the user from being rugged, right? You want to protect from malicious players. So if you fetch this information from somewhere else, for example, the quote of exchange ratio, and you process that in the server and you give that for the person would need to believe you that you did not change or omit this information, right? So whenever you do that for your end user directly, you do this fetch from the client side, you are proving for them that you are not tampering with information. Okay, so we can do this client side fetching, so the user would go there and fetch that whole information by themselves. Okay, we don't need to gatekeep that connection. We don't have a user database and all. The user can go there and get that information directly. So I'm creating that function called random board, just as an example, calling this random user API. That is going to return some random information. Okay, it's not important what the API is returning. I'm just using an example with some random information. Okay, here you could imagine you're fetching some real information from somewhere. Okay, Lauren, do you have a question here?
Yes, I have a doubt. When we deploy a smart contract on the blockchain, let's say testnet or mainnet, is the code visible or is it a kind of a compiled code? So I mean, if I want to look at an application, can I read publicly all the code or it is like an executable? So maybe you have
Yes.
answered in previous lesson, but I have a doubt.
Yes, for example, this contract here, it is deployed by someone else. I can see the bytecode. And it's very simple to decompile that bytecode here.
So with this bytecode, there are some tools to reverse engineer and create some code.
Yeah, decompiling the name.
Okay. Okay. So it's kind of easy then to see the original code, right?
The original code, no, but you would see a code that would do the same thing that the original code would do.
Okay, a similar one.
Yeah, maybe the variable names are going to be different now, but the code is going to do the same thing.
Okay. Thanks for your explanation. Thanks.
Like we have here on this page.
I think he wants to go into the auditing part of the contract.
Yeah, it can be useful for auditing too. Okay.
So then if you have the code and it fetch data from off-chain, it will be very easy for someone to see the off-chain sources.
No, look, this maybe this is the explanation that I'm failing to convey. This is connecting the front end that is off-chain to fetch public information from off-chain. So it's off-chain, off-chain. So it is
Okay.
it's not doing anything on chain. It's not going to use smart contracts here. Okay.
Yeah, but your purpose was to say that if we corrupt the off-chain source, it can create issue on the blockchain.
No,
No.
Here was speaking about client side because there is server side rendering where the server serving this application would do this fetch and pass for the end user, and there is the client side rendering that you get the information directly. Okay, it's not blockchain related. It's about a front end infrastructure relation. Okay.
Okay. Thanks.
Yeah. It's like this. I call I call it stock exchange to get the price of Apple shares, and then I call you and I say, I don't know that Laurent. It's Laurent you are asking, right? Who's who I'm chatting with? Laurent, right?
Yes. Yes.
Sorry about that.
No,
It
it's
took me a
okay.
second here. So Laurent, I'm calling the stock exchange. They say that Apple is priced at $9, for example. Wouldn't it be better for you to call them and get this information directly? Because I might be fooling you. I might be tampering with the information to force you to buy my shares or to sell your shares to me, you know? So when you are doing this client-side fetch, you're getting this information by yourself. There are some situations that the APIs are not going to answer for you. They would answer for me, but not for you. In this situation here, on this example, they are public informations that we can get from anywhere without authentication or authorization. Okay. So it's not blockchain related. It is a front end to backend call here. So let me call this random board implementation from the page body. I don't need to put that inside the wallet info. I can put inside the page body. I don't need the wallet for that. So I'm going to put that in the page body, and I'm going to implement this call here, random mode, using this function called use effect, okay, from React. I need to import that. So I need to import use effect from React. This is going to do a change, an operation every time that the page is loaded. And then it's going to fetch this information from this API. It's going to set a data here in the state, ons, and it's not going to call again. And then whenever I have this data, I'm going to display whatever I'm receiving from the API. Okay? This API is very simple. It's just returning some random information for me. When I call this API, it's going to return some random data like this. This male, named Vincent, leaving that location. This is not a real data. It's just random data generated by this API. So when I do that inside my front end, this is the information that I received. The Miss Belinda Smith with this email being fetched there from that API. Okay. And you could use the signature to authenticate that call. There are many cool designs that you can do with these tools that I'm presenting today. Okay. Questions? Fetch information from an API. We did all of that on the on-chain part, fetch information from the blockchain, but here we can do the same thing for fetch information from off-chain sources. For example, a price feed or social media posts, news articles. We could call AI inferences here, ask an AI to generate this answer for me. Should I invest in that asset or no? Then call that for the AI. The AI is going to answer. I can fetch information, or I could even do post call, change information for any APIs. I'm going to change. I'm going to show those integrations in Thursday's lesson. Okay. For tomorrow, I'm going to introduce the subject of building these APIs ourselves. If we want to provide functionality with some server-side actions, some automated changes, like registering a user in a database, like minting tokens upon request from off-chain requests like airdrops. I want to give a token for anyone that posted about my company in the social medias. You can do that airdrop. I can do that with a backend. I want to automate trades whenever the Ethereum ETH price falls below 1,200, I'm going to buy. Whenever it goes after 1,800, I'm going to sell. So I can program this kind of automated functions in a backend that is going to be running without the need for a user to click on things, to click on buttons, to fill forms and all. So when to do a front end? When you need a user interface like that, when you need buttons, when you need forms, when you need to display information dialogue with users. When to do a backend, APIs, for example, when you want machines to talk with each other, when you want bots to talk, when you want automated services like this that are not meant for users, for human users, are meant for programs to work, systems. And yes, it is common to have backends for blockchain stuff. I'm going to show a lot of examples of that tomorrow. Okay. So to build a backend, we could simply run like a Node.js script like this, similar to the scripts we have run in the previous examples. For example, you can do this script here in 14 lines of code, and this would create a server for you. There are many things that need to be handled when creating a server. So you would need to code hundreds of thousands of lines of code to process everything correctly. I'm going to suggest a framework that handles all of that for us called Nest.js with an S. There is Next.js with an X that we used yesterday and today. And that is Nest.js, an S. I didn't name those, don't complain to me. It's just naming choices that these people do. That is a scalable Node.js server-side application. So Next.js is a full stack application. It can serve the front end and the back end, the serverless actions. It can deploy universal. Since the last two major versions, they are making it easier for you to deploy the back end in other places too. But this is still a little messy to coupled, in my opinion. I'm going to show how to decouple that because there are a lot of things that you might want to do with microservice, all the integration. So you don't want to do all of that inside Next.js. It would be very messy in most of the situations. You can still do some server action in Next.js, but having a proper full-fledged backend can be very useful. So I'm going to show this framework for you to build a scalable Node.js server-side application with full support for TypeScript, with a philosophy of conventions over configurations, similar to what you would have like React, Angular, and Vue to give those functionalities out of the box. You would build a Nest.js app. We're going to do the first steps in getting started tomorrow. It's basically this, those two comments. If you want to do that today for making it easier for tomorrow, you can. You're going to pick another folder on your computer. So we have here this D app folder, and you're going to run these two commands. You're going to run the installation, the global installation of the Next.js CLI, and then you're going to use this CLI for creating a project inside that folder. Okay, that will enable us to create that backend, and it's going to be much more simple and straightforward to apply a VM and the things that we did in the past lessons of this bootcamp to the backend than it was in the front end. You're going to see that. Okay. Abhinav, you have a question?
Yes, sir. Are we gonna soon build any D app from scratch in the coming courses?
Yes, we just did one like this. Built a one with not from scratch, but using scaffold ETH. Okay. And in this weekend project, we're going to build the app using front-end, back-end, and maybe even oracles. Okay.
I mean, if we, by using the React, can we, remove the Ethereum dev stack, welcome to scaffold ETH2? Can we remove those things?
Can you remove what? Sorry.
I mean, the things which are on the top, the header things, are they default or can we remove them?
Yes, you can. Everything that you have inside the scaffold ETH repository, it's able to be changed, it's able for you to tweak. Okay.
Okay, thank you.
Good, good. For today, this is it. We are above time already. I entered 1 minute delayed, finishing 1 minute delayed here too. Sorry about that. For tomorrow, try and have the Next.js installed so that you can run this command that we have in the quick start. Okay, we are going to go over this documentation tomorrow so that you have a project created, a nice new project name, okay, like API server or whatever. If you do that for today, pick the default option here, npm, whatever, and this is going to enable you for setting up your backend for tomorrow. Okay, that's it for today. I hope you have enjoyed. Any questions or issues, please let me know. Okay, bye bye.